Hello students, in today's video we will learn how to find the solution of a differential equation. Now see, for different types of differential equations we have different working procedure to find out their solution. अलग अलग तरह की differential equations होंगी जिन्हें हम study करेंगे और working procedures हम यहाँ पे सीखेंगे कि किस तरह से हम उनके solutions को find कर सकते हैं. So under that the first category which we are going to discuss in this video is Leibniz linear differential equation. The first topic which we are going to study is Leibniz linear differential equation. First we will see what is Leibniz linear differential equation. Then we will look for its working procedure, that how we can find the solution of Leibniz linear differential equation. Basically this Leibniz linear differential equation is a linear differential equation of first order and first degree. कोई भी इक्वेशन जिसका ऑर्डर भी वन होगा और डिग्री भी क्या होगी, वन होगी, और वो लीनियर भी होगी. डिग्री भी इक्वेशन की क्या है, वन. ऑर्डर भी कितना है, वन. सेकेंडली वो क्या है, लीनियर है. तो इस टाइप की इक्वेशंस को हम क्या बोलते हैं, लिबनिज लीनियर डिफरेंशियल इक्वेशन. इफ वी talk about its journal form, that how does it look like, this equation looks like dy by dx plus p of x times of y is equals to q of x, where p and q are functions of x only, are functions of x only, that is they will be free from y. And you can cross verify. See, what is the order here, 1. What is the degree, 1. And it's also linear. If you remember, what were the three conditions of linear differential equation? The power of derivative should be 1, the power of dependent variable should be 1, and they should not be multiplied together. All the conditions of being linear are satisfied here. So this is the journal form. And the next is, what is the working procedure to find the solution of this differential equation? For that we make use of concept which is integrating factor. Its value is given by e p of x dx. This is the value of integrating factor for the Leibniz equation. Leibniz equation में integrating factor का formula क्या है, exponential raised to power integration of p of x dx. Once you are done with this value, what you have to do is, the solution is given by dependent variable multiplied with integrating factor equals to integration of your right hand side function which is q multiplied with integrating factor dx plus c, where c is the constant of integration. Now what is the dependent variable here, y. So simply you can say your solution is y times integrating factor integration of qx multiplied with integrating factor with respect to x plus c. After solving this integration we will get the desired solution. Now see, sometimes what happens is, now the given differential equation is actually not linear in y. Like if you see, this equation was linear in y. Now sometimes the equations are not linear in y. Actually their form looks like dx upon dy, that is now x is dependent and y is independent. Then the equation will take this form, dx upon dy plus py into x is equals to qy. अभी हमारे पास इसकी अल्टरनेटिव फॉर्म हो गई है, जिसमें अब ये जो इक्वेशन है ये किसमें लीनियर है, लीनियर इन x. as you can see the degree of x is 1 here. So corresponding to that इंडिकेटिव फैक्टर की वैल्यू भी उसी तरह से चेंज हो जाएगी. नाउ इट विल बी एक्सपोनेंशियल रेज टू पावर इंटीग्रेशन ऑफ पी ऑफ वाई डी वाई. एंड इसका सोल्यूशन क्या बन जाएगा, अभी नाउ सोल्यूशन क्या, फॉर्मूला क्या था, डिपेंडेंट वेरिएबल इनटू इंटीग्रेटिंग फैक्टर. नाउ द डिपेंडेंट वेरिएबल इज x here, so the solution is solution x into integrating factor equals to integration of right hand side which is q of y into integrating factor. Now this is a function of y, so the integration will be with respect to y, so that's why I'm writing dy here plus c. This is how the things will work. Rest you will get the clear picture when we will solve the problems na. So this was all about the working procedure of Leibniz linear differential equation. And Leibniz linear differential equation is nothing, just it's a differential equation of first order and first degree which is linear. So let's have a look at an example. Solve the differential equation x log x dy by dx plus y is equals to 2 upon x log x. Now first of all we have to identify that whether this equation is Leibniz equation or not. Now I will write this equation like this: dy by dx plus y upon x log x. I have divided this equation by x log x so that I can make the coefficient of dy by dx as unity. Now this will become 2 by x log x divided by x log x. Simplifying this equation, and we get 1 by x log x times y. This will be log x is getting cancelled out here, 2 by x square. Now if you compare this equation 1 comparing with general form dy by dx p of x y is equals to qx, we get p is equals to 1 by x log x and q is equals to 2 upon x square. So this equation is now Leibniz equation. You can see dy by dx plus some function of x times y is equals to q of x. कंपेयर करने पे p की वैल्यू भी मिल गई है और हमें q की वैल्यू भी मिल गई है. Now the first step is to find out the value of integrating factor e raised to power integral p of x dx, which is e raised to power 1 by x log x dx. Now the task is to solve this integration. For this you can use the direct formula as well. I will show you the working procedure by using substitution. डायरेक्ट फॉर्मूला भी यूज़ कर सकते हो बच्चे यहाँ पे आप इंटीग्रेशन का, लेकिन मैं यहाँ पे आपको सब्सटीट्यूशन के साथ सॉल्व करके दिखा देती हूँ. यूज द सब्सटीट्यूशन, पुट log x इज इक्वल्स टू z डिफरेंशिएशन 1 by x dx is equals to dz. So what we will get here, exponential integration of 1 by z dz, and integration of 1 by z is log z. Now which gives us equals to z, and the again back substitution, value of z is log x. So the value of my integrating factor is log x. Now the second step, which is solution. Solution is given by dependent variable, that is y, times of integrating factor equals to q of x into integrating factor times of dx plus c. And all, make sure that you write the formula, whatever formula you are using there in the problem na, do mention there. Formula जरूर लिख के आया करो बच्चे एग्जाम में. So now y into log x is equals to q. The value of q was 2 upon x square into log x dx plus c. Now 2 is a constant, I am taking it outside, and this is now 1 by x square log x dx plus c, where c is the constant of integration. Now we have to solve this integration. For this I am going to use by parts by considering log x as first function and 1 by x square as second function. So we get this is equals to 2. If you remember, let me write the formula for by parts. Let's say this is first function and second function. The formula is for integration by parts, first function as it is, integration of second minus derivative of first function multiplied with integration of second and then their whole integration. This is what I am going to use here. So applying that, log x as it is, integration of 1 by x square dx minus derivative of log x integration of 1 by x square dx whole bracket, then again integration with respect to x plus constant of integration c. Now 2 log x integration of 1 by x square is minus 1 by x minus integration derivative of log x 1 by x integration minus 1 by x plus c. Sorry, there is dx here now. So this is 2 log x, negative of log x upon x, this negative and negative, positive, integration of 1 by x square dx plus c, 2 times of minus log x upon x, again integration of 1 by x square is minus 1 by x plus c, taking negative common, I can write minus 2 log x plus 1 by x plus c. On left side there was y times of log x. This is your required solution. Now let's solve one more example of similar type. Solve the differential equation x plus 2y cube dy by dx is equals to y. Now we have to solve this equation. Now if you closely observe this equation, although this equation is of order 1, right? Is it of degree 1? Yes, true. But this equation is not linear in y. Why so? See, look at this y cube. If you recall the definition of linear differential equation, it says that the dependent variable should be of degree 1. But what is happening here? It's present here y cube. So it means this equation can't be linear in y. तो वो वाली type तो लगेगी ही नहीं. And now I will try to check whether this equation is linear in x. See, if you remember, let me show you. The linear Leibniz differential equation can be of two forms. Linear in y, in which the dependent variable y is of degree 1, or it can be linear in x as well, in which we can make x as dependent variable, y as independent, if the power of x is 1 there and all the other conditions of being linear are also satisfied. अगर बच्चे इक्वेशन इस टाइप में मॉडिफाई नहीं हो रही है तो हम क्या कर सकते हैं, हम ये चेक कर लेते हैं कि क्या उसको हम एक्स में लीनियर बना सकते हैं. अब उस क्वेश्चन में हम यही चीज़ चेक करने वाले हैं. What I will do here, I will convert this equation into the form of dx upon dy. Now let's see if we are successful or not. Na? So we can write this equation as x plus 2y cube. Shift this y to left side. So this will go in denominator, and this term dy by dx to the other side, dx upon dy. Rearrange the terms, you will get dx upon dy is equals to x upon y plus 2y square. Shift this to the left side, dx upon dy minus 1 by y x is equals to 2y square. If you see, now this equation is linear in x, first order, first degree. डिग्री ऑफ एक्स इज ऑल्सो 1. डेरिवेटिव भी हमारे फर्स्ट ऑर्डर का है, उसकी भी डिग्री 1 है. डिपेंडेंट वेरिएबल क्या है? एक्स, डिग्री 1. डिपेंडेंट वेरिएबल और डेरिवेटिव्स मल्टीप्लाइड भी नहीं है. ऑल द कंडीशंस ऑफ बीइंग लीनियर आर सेटिस्फाइड एंड दिस इक्वेशन नाउ लुक्स लाइक dx upon dy plus pyx is equals to q of y. If you compare, the value of p is minus 1 by y. Be careful of this negative sign. And q of y is 2y square. Now we will calculate its integrating factor. The integrating factor is given by exponential. It is now p of y dy. Na? Be careful about that. And the value of p of y was minus 1 by y dy. Integration of 1 by y is log y. It can be written like e raised to log y raised to power minus 1. Now what we have done here, we have used the property of log function, that m log n can be written as log n raised to power m. ये प्रॉपर्टी होती है हमारे पास log function की ना. So this is what I used here. The negative was here, I shifted that to the power of y. So integrating factor is y raised to minus 1, or you can say simply 1 by 5. So we are at our second step now, solution, which is given by dependent variable. Now in this case dependent variable is x times of integrating factor, right hand side is integration of q of y into integrating factor with respect to dy plus c, where c is the constant of integration. So this is x into 1 by y is equals to integration of q. Our q was 2y square into 1 by y dy plus c. Simplifying this, 2 outside, y square upon y, simply y dy plus c. Left side it was x upon y, na? So this is x upon y 2. Integration of y is y square by 2 plus c. 2 is getting cancelled here. Shift this y to other side. You get x is equals to y cube plus cy, which is your required solution. So this was all about how to find the solution of Leibniz linear differential equation, and we have discussed both the types, the one which is linear in y and the other which is linear in x. Still, if you have any queries, do let me know. We will discuss them in next lecture, next video. Thank you.